Good afternoon, girls. In the oxidation reduction chapter, we go for the first one, that is oxidation. Based on the atoms, the definition for oxidation is nothing but gain of oxygen or loss of hydrogen. So, based on the electrons theory, the loss of electrons or increase in oxidation number is called as oxidation. The down one, which is opposite to the above definition, is called as a reduction. That is, a decrease in oxidation number and gain of electrons. Okay, the chapter will go for based on the oxidizing agents, the substance or substrates or a reactants which has the ability to oxidize the other substance or the starting material. It's called as oxidizing agents, right? So first one is nothing but the strong oxidizing agents, nothing other than your potassium permanganate and chromic acid. A potassium permanganate is a strong oxidizing agent which can easily oxidizes the alkenes, alkynes, weak carbon hydrogen bonds, and the same time weak carbon carbon bonds also. So what are the substrates the potassium permanganate is oxidizes means? First one is nothing but aldehydes. The aldehyde is easily oxidizes to a acid in presence of potassium permanganate. The next one is alcohols. The alcohols are also oxidizes to acid. Intermediate is nothing but the aldehyde, but we can't separate it from the reaction because it is a fast one. So the alcohols are within seconds it can oxidizes into a acid. Then it oxidizes the pi bonds, that is here pi bonds means a double bond or a triple bond. Here I gave the example of a cyclohexene. One cyclohexene, it consists of only one bond. Without bond it's called as cyclohexane. It is consists of a one bond, so you have to call it as a cyclohexene. You have to number, then it will comes as this one as 1 and 2. So it is called as 1 cyclohexene. The 1 cyclohexene undergoes a reaction with potassium permanganate. It converted into a manganese diester, which is an intermediate. Then it can hydrolyzes into a corresponding diols. At the same time, if in addition with heat, this is a room temperature reaction. If you add a heat to the reaction, automatically the bond will get broke up and the closed, that is the cyclic compound, is converted into a open chain compound, that is they are converted into a dioic acids, that is diacids. Other than that, the alkynes are also oxidizes into a diketones in presence of potassium permanganate. Aromatic side chains are also oxidizes in presence of potassium permanganate. That is, this is a nothing but what is this? This is a toluene, right? The benzene ring attached with CH3, it is called as a toluene. A toluene is oxidizes in presence of potassium permanganate into a benzoic acid. Right, up to this, these are the reactions the potassium permanganate is undergo as a strong oxidizing agent, and it oxidizes into a corresponding acids directly maximum. Then the second one is nothing but the chromic acid. The chromic acid molecular formula is H2CrO4, and it is prepared by the reactions when the potassium or sodium dichromates reacts with sulfuric acid or otherwise with the chromium trioxide with the water also. It can convert it into a chromic acid, which is the best cleaning agent for glass apparatus in our laboratories also. Whatever the stain in the glass vessels, it can go off if you use or clean with the chromic acid, right? This is the extra point. And if you come for the reactions, primary and secondary alcohols are undergo a reaction with chromic acid, right? So primary alcohol in presence of chromic acid, it is converted into a acid. At the same time, if a secondary alcohol is undergo a reaction with chromic acid, it converted into a corresponding ketones. If aldehyde is reacts with the chromic acid, then it is converted into a corresponding acid. Right, after that the strong oxidizing agent, we come for the mild oxidizing agent. In the mild oxidizing agent, the first one is nothing but the OS, that is osmium reagents, that is osmium tetroxide. This is called as osmium tetroxide. This is used to oxidize the pi bonds, right? The pi bond containing compounds are nothing but your olefins or alkenes, right? Olefins are nothing but they only consist of a double bonds, right? It may be alternative double bonds or it may be a non-conjugated or conjugated double bonds. It's nothing but your olefins. Right, so here I gave one alkene in presence of osmium tetroxide, undergo hydrolysis, it converted into a diols, right? Then other than these strong and weak oxidizing agent, the opinion oxidation is the one of the important oxidation process, right? What is the definition for your opinion oxidation means? Opinion oxidation is nothing but the oxidation of primary and secondary alcohol with a ketone, right? Maximum the ketone will be a acetone. That is the oxidation of primary and secondary alcohol with a ketone in presence of metal alkoxide, right? The main metal alkoxides we are using here is aluminium, that is a metal, and alkoxides are nothing but you can use a tetroxide, isopropoxide or pentoxide, which one you want you can use that. The products are nothing but corresponding aldehyde and ketone. So the definition, whole definition is oxidation of primary and secondary alcohol with a ketone in presence of a metal alkoxide and converted or leads to a corresponding aldehyde or ketone. So here this is the example for the reaction, that is the general reaction of your opinion oxidation. This is nothing but a secondary, right? The either side is R and R dash and one OH is between, so it's called as a secondary alcohol reacts with the ketone in presence of heat and aluminium isopropoxide, it converted into, that is the secondary alcohol is converted into a ketone along with the one alcohol, ketone along with the alcohol. So what are the advantages or applications of your opinion oxidation? I gave here. So the first one, the opinion oxidation is nothing but it is a mild oxidation. It won't go for a over oxidation. That is, it easily converts your alcohol into a that is primary alcohol into a aldehyde, secondary alcohol into a ketone, not to the extent of become a acids, right? So there is no over oxidation, it is a mild oxidation process. And next one, it is only attended or attacked the OH and it is tolerated by the maximum of other substituents, right? If a molecule consists of many that is CH3 or otherwise it consists of other pi bonds, then also it won't affect that pi bonds or CH3s or other substituents Cl which are not affected by your opinion oxidation. In this process it just only affect your primary and secondary alcohol, that one only in the second point, right? Here we can use aluminium alkoxide, I already explained that, and wide range of substrates are oxidized by this, and the oxidation of 1,4 or 1,5, that is nearby diols or leads to a lactones. Lactones is nothing but a oxygen substituted cyclic rings, right? In that ring one of the carbon is nothing but replaced with the oxygen and it having a one ketone group, that is called as the cyclic 6-membered or 7-membered or 8-membered cyclic ring. In that ring one of the carbon is replaced with the oxygen and also it substituted with the one ketone, that is called as lactone. So 1,4 or 1,5 diols are easily leads to the formation of lactones. Then acetone is mostly used substituent in this opinion oxidation because of its low reduction potential. And these are the applications, the advantages of your opinion oxidation. So next important oxidation reaction is ozonolysis, that is the oxidation of olefins in presence of ozone, right? So here the olefin is nothing but a double bonded compound. In presence of ozone, it will converted or it will broke up. The double bonds or will get broke up. Here we can use H or so here I get H, but here I wrote R. So both are, we can, R is nothing but either H or other substituents. So if you want to write, you can replace with that is R only for your clear purpose, R and R dash. So we can get the double bond will get broke up. The double bond will get broke up. We get two types of ketones here. Right. Next one is paracids. Right. This is the other oxidizing, mild oxidizing agent, which one leads to a epoxide. That is, if a alkene or a olefins are undergo a reaction in presence of paracid, then it produces a corresponding epoxide.